Okay, so we're going to look at congruent figures today. Okay, so we looked at rigid transformations, and we did this specifically in Unit 2. And what we learned about rigid transformations is that the three rigid transformations preserve angle measures and side lengths. So if something is in fact a rigid transformation, the angle measures and the side lengths will be preserved. So the angle measures and the side lengths will not change in value or size. So they did have three types of rigid transformation. The first was reflection, which we often refer to as a flip in a plane. This can help us. So flip. We have a translation, which is often referred to as a slide in a plane. And then we had a rotation, which is often referred to as a turn in a plane. Okay, so we had all these three different types of transformations, each of which preserves the side lengths. So the side lengths and the sides of the angles does not change, it stays the same. So what we know about congruent figures is if two figures are congruent, these two figures are congruent if and only if they are mapped onto one another by one or more rigid transformations. So basically, if we were to apply rigid transformation to a figure, and we knew that that transformation was in fact rigid, then what we would know from that is those two figures have to be congruent to each other. Because again, rigid transformations do not change the side lengths or the angle measures. So for example, here we have figure ABCD, which is mapped to A prime, B prime, C prime, and D prime. And we're told this is done by a rigid transformation. Because we know that we have mapped it from the original to the pre-image to the image about a rigid transformation, what we can assume from that is that these two figures will be congruent. Because if we apply a rigid transformation, then those two figures remain congruent. Okay, meaning that us saying that they're congruent means that all the angle measures are the same. So this angle measure would stay the same as that angle measure. This angle measure would stay the same as that angle measure. This one as this one. This one as this one. And all the side lengths would stay the same. So nothing changes. The only thing that happens is it can be flipped, turned, or slid to map to wherever it is on this other side. But other than that, nothing really changes. Okay, here we have another example. This one says if QRST is congruent to Q prime, R prime, S prime, and T prime, then what we can assume from that is there must have been a rigid transformation applied because only rigid transformations allow for our two figures to remain congruent. So here we're told that these two figures are congruent, and so therefore one or more rigid transformation must have been applied to them. Only rigid transformations can be applied for two figures to remain congruent. If something that is not a rigid transformation is applied to a figure, then that figure will obviously not stay congruent. Remember that we only have three types of rigid transformations. We have a reflection, a translation, and a rotation. These are the only types of transformations that can occur and that will keep my figure congruent. If I have a different type of transformation occurring, then my figure will no longer be congruent. For example, here I have JKL has been rotated 90 degrees about point P. Rotated is in fact a rigid transformation, but then it tells me it is followed by a deletion by a scale factor of 2. Well, a deletion, what you'll notice, is not a rigid transformation. And so because a deletion is not a rigid transformation, what that tells me is that my figure does not stay congruent. And you can also see that as my figure has increased, right? This triangle is a lot bigger than my original triangles. And because of that, those two figures will not be congruent, or all three of those figures will not be congruent. Okay, so figures only stay congruent if a rigid transformation is applied. So only a rotation, a reflection, or a translation. So here's an example of congruence. Triangle DEF has been rotated, followed by a reflection. Rotation is a type of rigid transformation, and a reflection is a type of rigid transformation. And so because both of those are rigid transformations, that tells me that my triangle will remain congruent throughout each of these different types of transformations. Okay, so once again, deletion is not a rigid transformation because it does not preserve segment length or angle measure, a single non-rigid transformation or a composition that contains a non-rigid transformation will not produce congruent figures. So whenever we're looking through congruent figures, what we want to note is that all we're looking for is these types of rigid transformations. If you have a transformation that is not one of these three, well, then you can automatically assume your figure will no longer be congruent. Okay. So here's an example. This one's asking, is DEFG and WXYZ congruent figures? Well, here will be our pre-image. And what I'm trying to determine is this image congruent to this resulting image? This will be my resulting image. Well, let's see. What we're looking for is what types of transformations have been applied, and are those transformations rigid transformations? So DEFG has been mapped to D prime, E prime, F prime, and G prime by a translation. Is my translation a type of rigid transformation? Yes, it is. So it remains congruent right there. Then D prime, E prime, F prime, and G prime is mapped to X, W, Z, Y by a reflection across the y-axis. Is my reflection a type of rigid transformation? Yes, it is. And so because both of my different transformations were types of rigid transformations, remember we only have three, that tells me that yes, those two would end up being congruent to each other. Okay. So if all the types of transformations that are applied are rigid transformations, then my resulting image would in fact be congruent to my beginning image. Okay, questions about this? So whenever we're trying to determine are two figures congruent to each other, what we want to identify is, are we applying only rigid transformations? If we're applying only rigid transformations, then yes, my figures will remain congruent. If I apply something that is not a rigid transformation, then my figures will no longer be congruent to each other. Okay, so now we're going to look at the corresponding parts of congruent figures. Basically, what this states is that if two figures are congruent, then the corresponding parts are congruent. So basically, if I've determined already that two figures are congruent, then all their parts will be congruent. Okay. So, for example, here I'm told the triangle ABC is congruent to triangle DEF. So I'm told already that these two figures are congruent to each other. This triangle is congruent to this triangle. Given that information, what I can determine is what pairs of sides and pairs of angles are congruent to each other. So because these two triangles are congruent to each other, what I can determine from that is that all my parts will be congruent to each other. So here I'm told some information about congruent parts. I'm told that AB is congruent to DC because they both contain that one dash. So AB is congruent to DC or DE. Here I can see two dashes here and two dashes here. Those two tells me those two are congruent to each other. So BC is congruent to EF. And what I can also tell is that this angle is congruent to this angle because they both contain that similar symbol. So angle B is congruent to angle E. Okay. So what I'm able to tell from the corresponding parts of figures, congruent figures theorem, is that these two triangles will be congruent to each other in every single one of those parts. So if these two triangles are congruent, then all their parts will be congruent to each other. That means even my other angles that I'm missing, I can determine that those would be congruent to each other too. So this would be congruent to this one, and this one would also be congruent to this one. So all my parts would be congruent to each other if those two figures are in fact congruent. So we'll see a better example of this right now. Here I'm told that these two figures are congruent to each other, right? These two figures are congruent to each other. That being said, find the measure of all the sides and angles of both figures. Well, like I said, if both of these two figures are congruent to each other, then their parts are congruent to each other. Basically, they're the exact same figure. If these two figures are congruent, then they're the exact same figure, which means all their parts are basically the same. So that being said, what I can do is take information from this figure and put it into this figure, and take all the information from this figure and put it over to this figure. The reason that I can do that is because those two figures are congruent, so basically they're one and the same, they're exact same thing. So I can find out where to put my parts. So I'm going to start here. Here I notice that I have a right angle. Over here, I could estimate that the right angle would be about right there. Okay. What I realize here is that right next to my right angle, I have an 8 centimeter line segment. And so that would be this line right here. So 8 centimeters. What I also know is that this and this line segment are congruent to each other. And so this would also be 8 centimeters, which means my line segment on the bottom of my right angle has to also be 8 centimeters. This would also be 8 centimeters. And I also have this 49-degree angle. What I noticed is that 49-degree angle is located somewhere where there's kind of a point protruding out, which looks like this point right there. So that would also be 49. So basically what I'm able to do is determine that because these two figures are congruent, basically they're exactly the same. So everything that's going to be on this figure is going to appear on this figure, and everything that's on this figure will appear on this figure. So now I've put everything on this figure over here. So now let me see what else I'm missing. Here, what I noticed is I have a 15 centimeter line segment on the very top. And so that would be right here. Let's see what else. I have 10.6 centimeters at like this slanted diagonal area, which is mapping right here, right? We can kind of see that right there. That would be 10.6 centimeters. Let's see what else we have. We have that opposite, that 90-degree angle is 127 degrees. And it looks like what we're also missing is opposite, or on top of that right angle, we have 94 degrees. So basically what I've done is I've taken all my parts and added them to my figures. And now you will see that what I've created is two exactly congruent figures. So those, we were told those two figures are congruent, but now they're extra congruent because all their parts match. See, all the parts match. So basically, if two figures are told to be congruent, then all their parts will be the same. All their angles will be the same, all their side lengths will be the same. That's basically what this idea is telling us. The corresponding parts of congruent figures idea. Okay? So here's just a quick example of a problem we might see. Give me 1 second. Okay. This one's a little bit more complicated, but we'll work through some more examples later. Basically what it says, Emma forms the frame of a roof from a shed by combining two congruent right angles. So what I know is these two angles are congruent to each other. That being said, what I can determine from that is that their parts will be congruent. So if this part has a right angle, this part will have a right angle. If this part is 3 feet, this part will also be 3 feet. If this line segment is 4 feet, then this line segment will also be 4 feet. Right? So because I know those two triangles are congruent to each other, I know that their parts will be congruent to each other. Now it's telling us to find the perimeter and the area of the entire frame. Okay? In order to find the area of triangles, what we use is the equation 1/2 base times height. So 1/2 the length of our base. So 4 plus 4, this is the length of our entire base. 8 times height. How tall is my triangles? 3. 1/2, 24 equals 12 feet. So that is my area. Now to find the perimeter. To find the perimeter, we add all of our components together. So I'm adding 4 plus 4. And then what I need to identify is what is the measure of these. I know the measures of these will be equal to each other because, again, those two figures are congruent. But I need to go ahead and find what that missing side length is because my perimeter has to be all this. outer portion. And so I need those two side lengths, okay? Whenever I have a right triangle, I use the Pythagorean theorem to find my missing side length. So 9 plus 16 equals C2. 25 equals C squared. To get rid of your squared, you square root both sides. C is equal to 5. So now that I know that this is equal to 5, and I know that this is equal to 5 because those two are congruent to each other, so they have equal parts. So plus 5, that tells me my perimeter is equal to 18 feet. So what I'm able to do with this problem is because I know that those two figures are congruent to each other, what I can go ahead and do is I can identify the matching parts. Obviously, if those two figures are congruent to each other, they're going to have equal parts. So all the side lengths are going to be the same, all the angle measures are going to be the same. Using that information, I can find my perimeter and my area. But again, this one's a little more complicated because you do have to take into consideration the Pythagorean theorem, which we worked on briefly. But again, we'll go ahead and review it if we do see problems like that, okay? Most of the problems you will see, however, have to deal with determining if two figures are congruent, if a rigid transformation is applied, or if I know that two figures are congruent, and then I know that those parts will equal each other. So you'll just fill in those missing parts. We'll go over some example problems tomorrow. If there's no other questions, you guys may log off. And I will see you guys tomorrow. Bye, guys. Bye.